Hey guys, this is Mr. Fu. This should be video number 1. We're going to go over the topics A, B, and C. These deal with transformations, different representations of square root functions, and also domain and range. The problems that this video covers are 4, 9, 12, 19, 1, 6, 7, 2, 10, and number 20. So I will go through a couple of example problems on each one of those sections. So for number 4, says describe the transformation f of x equals 1/2 times the square root of x minus 2 minus 10. So we have to figure out the transformation for this square root function. So the first thing that I notice is, well, the parent function in this case is the square root function because we have this square root sign. The next thing is, let's go from left to right to figure out exactly what these transformations are. So the first number that I notice is this 1/2. Now, because I know this 1/2 is being multiplied by this square root, this 1/2 must affect the function by either vertically stretching it or vertically compressing it. Since 1/2 is less than 1, I know then that this function is being vertically vertically compressed. Then I look at this minus 2 on the inside of the radical sign. Because it's minus 2, and it's on the inside of the radical sign, we think that this shifts the function left and right. And because it's minus, and when it's shifting left or right, we think about Michael Jackson's moonwalking. So minus actually means that the function shifts to the right by 2. And lastly, there's one last transformation, which is this minus 10, and it's on the outside of the square root sign. So I know this minus 10, if it's on the outside, must move this function up or down, and in this case, since it's minus, it must move this function down by 10. So the correct answer for number 4 should be vertically compressed, right 2, and down 10. Let's take a look at one more example. So what about for number 9? Same thing. Describe the transformation f of x equals 9/2 times the square root of the quantity x plus 1 plus 20. So let's look at these together. So the first thing I notice again is this number that's being multiplied by the square root function. Now, this time you have to be very careful. 9/2, although it is a fraction, 9/2 is greater than 1. Since it's greater than 1, I know that this must vertically stretch the function because 9/2 is greater than 1. Now the second thing I notice is this plus 1 on the inside of the square root sign. Now remember last time when it was minus 2, we shifted it to the right by 2. So therefore, if it's plus 1 on the inside of the radical, it must shift the function to the left by 1. And lastly, this plus 20 on the outside will shift the function up or down. And since it's plus 20 on the outside, it must shift the function up by 20. And the important thing is that this is on the outside of the radical, and this plus 1 is on the inside of the radical. Alright, so that's transformations. Now, what about when we have to deal with matching the table with the correct equation? This one could be good. Could be a little bit tricky. The nice thing about this question is that I actually gave you the answer choices, and we know that one of these must be the correct answer. So one way to go through this type of problem is just to plug in a couple of these numbers, and since you guys have the help of your calculators, this shouldn't be so bad. But let's take a look at how we can do this even without calculator's help. So let's take a look. Well, when x equals 0, I know the function must be undefined. In other words, when x equals 0, whatever is underneath the square root must be a negative sign. Must be a negative number, excuse me. That means that it's undefined. So let's plug in 0 in a couple of these to see if it gives us an undefined answer. So if I plug in 0 in this first one, the square root of 0 is defined because I know the square root of 0 just equals 0. So therefore it cannot be the first option. Okay, let's plug in 0 into number 2. 0 minus 3 is negative 3. The square root of negative 3 is undefined. So it could be letter B. Let's move on. What about C? The square root of 0 plus 1 is actually the square root of 1, which is defined, but we want undefined, so it can't be letter C. And lastly, if I plug in 0 here, let's see, the square root of 0 minus 1 is the square root of negative 1, which is undefined. Okay, so it could also be letter B. However, we eliminated 2 of the answer choices. Let's keep going. What happens if x equals 1? We need to get f of x to be 4. So let's plug in 1 into our first equation. If I plug in 1 here, alright, I'll put this bar here to know that we're doing 1 now. The square root of 1 minus 3 is basically the square root of negative 2, which is still undefined. That can't be right. We need 4. So it cannot be b. Now what happens if we plug in 1 into the letter D choice? Okay, let's see. The square root of 2 minus 1 plus 3, what does that equal? The square root of 1 plus 3, which is just 1 plus 3, or 4. Hey, that's what we're looking for, right? F of x must equal 4, so it must be letter D. See, in this case, we didn't even have to go through when x equals 4 or when x equals 9, because just these 2 x values got us to eliminate all 3 of these answer choices. Now, if you really wanted to check, you can also plug in 4 into this function for x, and you should be able to get 5.646 using your calculators. Similarly, if you plug in 9 into this x, you should be able to get 7.123 if you evaluate f of 9. Alright, so this is one approach to solve this type of problem. Number 10 deals with domain and ranges of square root functions. Now remember, domains deal with x values and ranges deal with y values. So let's see how we can define domain and ranges. So for number 10, it only asks us for the range. However, let's take a look at both of these. So for the domain, we care about the x values. So let's see where the function starts off in terms of the x values. So here are the x values, and I see that the function starts off right there. So in that case, let me draw this dashed line here to indicate that this is the x value that the function starts off at, which in this case is 1, 2, 3. So the x coordinate here, I know it's 3, and the y coordinate is negative 1. Now where does this function end in terms of the x values? Well, let's keep going to the right. Well, this function seems like it's going on forever, so it's going to keep on going until infinity in terms of the x values. Therefore, now I can define my domain. My domain must start off at 3, and then it must end at infinity. And remember, when it's infinity, we must put this parentheses, and the 3 requires a bracket because the point is defined at 3. Now, similarly, let's take a look at the range. However, ranges deal with y values, which means that we must think about the y values when considering how this function is being defined. Now let's take a look at the bottom of this function to the top of this function. Where does this function start at the bottom? Well, luckily it starts at the same place. So let's draw this horizontal line to indicate that it starts right here in terms of the y values now. What is the y value at the starting point? Well, it's not 3 anymore, it's negative 1. So the y value here starts at negative 1, and let's see where this function ends if we look upwards. Thinking upwards, I know this function keeps on going forever, and it keeps on going forever upwards, so it must end also at positive infinity. Now in this case, let's go from the bottom to the top and define our range. So again, we must start at negative 1. At the same point, however, we care about the y values now, and then we end at positive infinity. I need a bracket at negative 1, again, because negative 1 is included in this function. It's defined right there. And we use this parentheses at infinity because we can never include the number infinity. So the final answer for number 10 should be negative 1 to infinity.